All right, just a quick look at number 6 here. I'm just going to whip through the solutions to this real quick, and hopefully you guys can figure out what's going on there. So if this is my function, looks like they're calling it f of x here. Well, is it a function to begin with? So looks like for every x value that I've got here, there's at most one y value. So yeah, it's a function. It passes my vertical line test, right? So yes. Let's take a look at the domain. So I've got my arrows on the outside here. So this one is implying that this goes up and out forever. So my domain, all the places where there's graph above or below the x-axis is going to go from, this goes out forever, so minus infinity. And then where's the first place? I can't include the minus infinity because I can't really put my pencil on a minus infinity. It's just an idea. So I use the round bracket there. Say it's not included. And then the first place that I run into a domain restriction looks like at minus 3. There's nothing above or below the x-axis there. I've got an open circle there, and there's nothing anyplace else. So that means that I've got to make sure that minus 3 is not included in my domain. So I use the round bracket to say that, negative 3.0.000000001 would be included, but when I put my pencil right on negative 3, nothing's there. Okay, so that goes on both sides. And then looks like I keep going here at 2. There's nothing on this side of the graph for 2, but there is one up here. So there is a value for x. So that one stays. I don't have to do a domain restriction for that. And then it looks like there's graph above or below the x-axis everywhere out to positive infinity there. Okay, round bracket again. So the range, where is their graph to the left or right of the y-axis? So I start moving from the bottom of my range, and the first place that I actually get graph is at minus 3. So that's the start of my range. Is that minus 3 defined there or included? Sure it is. So I need a square bracket. All of these places, there's graph at minus 3. I move up to negative 2, and I see that there's a hole here, but because this graph looks like it's got a point there, I've still got a graph to the right of the y-axis at negative 2, so it's included, so I don't do anything there. There's graph all the way up to here, and then graph all the way up to infinity. So there really are no places where there's a range restriction there. Okay, so here we go. What's f of 1? Okay, what they're really asking here, this is the same as asking this. If I want to complete the point, 1 question mark, what's the answer? This notation means the exact same thing as this. So I go over to 1, and I see what's the height of the graph at 1, and it looks like 2. So that equals 2. Okay. In E, it's the opposite, right? It's saying what's the height of the graph, or where is the height of the graph, equal to 1. So this question is more asking this. At what x value is the height of my graph 1, or what x values? So we go look at the height is 1. You can put a horizontal line out there. Looks like here's one of them. So x is equal to 1. Okay, that's one place. That's one x value where the height is 1. And another one, not here, it's open circle there. It looks like right around, let's say, I don't know, I have to estimate, 8.2. So the graph is a height of 1 at x is equal to 1 and x is equal to 8.2. Okay, same thing here. This means When 0 goes in, what comes out? 0 goes in, well 1 comes out. We already done this one. Okay, so this is equal to 1. Where is f of x equal to 0? When is the height of the graph, f of x, equal to 0? So they're asking this question, at what x's is my height 0? So let's go and look at them here. Looks like at x is equal to minus 1. And what else do we got here? X is equal to minus 1 is the height of 0. X is equal to 4. And x is equal to 8. Okay. Now, where is f of x less than or equal to 0? So what does that actually mean when I look at the graph? It sounds like when is the height of the graph less than or equal to 0? And they're asking us to find the x values. So that's going to be an interval, right? Because all of these places here, let's do a different color. All of these places here where the graph is under the x-axis is when the value is less than 0, right? Here's 0. When is the height less than 0? That's what this question is asking me. So I need to use an interval. So all of these places from negative infinity, okay, again, round bracket, to, we got to exclude the negative 3, to negative 3. And we start it up again. And then from negative 3, it looks like till negative 1. All of these values are underneath the x-axis. So from negative 3 to negative 1. And because I've got an equal sign here, right, that means that that 1 is going to be included in my interval. Is the height of the graph equal to 0 at negative 1? Yeah, it is. So I have to include the 1. Okay, and then I've got a union here, right? All of these places from negative 1 to looks like around 4, the graph is greater than 0. So I want to put a union, and then starting at 4 again, and going to looks like 8, included as well, the graph is going to be less than or equal to 0. Okay, and then the justification. What are we going to say here? All the x values where the graph is under the x-axis. Okay. So what are the zeros? Zeros are just the places where the graph crosses the x-axis. So the zeros here look like negative 1 and 0. 4 and 0 and 8 and 0. Okay, so these are coordinates now. We're just talking about the actual points where the graph crosses the x-axis. Okay, so when you see zeros, it looks like, here we've got an interval, which is implied from the inequality here, and here we've got points because they're asking for zeros. Okay, what is the y-intercept? Only crosses the y-intercept at 0 and 1. Okay, again, a point. And now it's asking us about a one-to-one function. Is this one-to-one? So up here we said it was a function because for every x there's at most one y value. Okay, but for one-to-one, it changes it, or it adds to that classification, and we want to say there's also for every y only one x value. So for a function, you check with the vertical line test. Okay, is there ever only one y for each x? But then for one-to-one, you do that, and as well, you're going to say, is there for every y value only one x? So that means that you can only have one x value. And here there's a bunch of places, like for 2x, for example, there's 2 x's where the height of the graph is 2. Down here, if I go to 0, there's 1, 2, 3 values for x at the height of 0. So this function does not pass the horizontal line test, so it is not 1 to 1, because it does not pass the horizontal line test, right? I can put a horizontal line down and it crosses the graph in multiple places, okay? So for it to be 1 to 1, it's got to be a function. There's got to be, for every x, there can only be at most one y. But then, in addition, for a 1 to 1 function, each y can only have one x. And in here, there's multiple x's for a couple of y's. Okay? So now increasing, decreasing intervals. Okay? Give the intervals where f is increasing. So that means from left to right. For all of these, the way we read this graph is we start out at minus infinity and we start dragging it along like a movie here. Okay? And as soon as the graph starts increasing from one x value to the next, from left to right, that means that we've got an increasing graph, right? It's going up. So my first increasing interval is going to start at minus 4. Okay? And we're going to put a round bracket there. We're going to say for class that you can never have a function increasing or decreasing at a point. Okay, so we're always going to use round brackets for increasing, decreasing, and constant intervals. Okay, so increasing from minus 4, then it starts going up. We got to exclude minus 3 again. And it keeps increasing all the way up to x is equal to 2. So we're just writing the places along the x-axis where the graph is moving up from left to right. Okay, so that's the first interval there, but it looks like then it starts to go down, down, and right here at x is equal to 7, so I leave a union there, and at x is equal to 7, I'm going to start to increase, and it looks like it's going to increase all the way up to infinity there. Okay, so where's the graph decreasing? Well, I look at all the places where the graph is going down from left to right, and it looks like this is my winner here. In between 2 and 7, I could run my pencil along the graph, and it'd always be going down from left to right. So that's my interval. So from 2 until 7. Whereas f constant means it's going to be the same. So it's not going up or down, it's just going to be the same where the function is. So this looks like from minus infinity to negative 4. And then finally, what's f of 2? So f of 2, it takes you over here. There's nothing really at this open circle. So I go up and go to where there's a solid point. And it looks like f of 2 is equal to 3. So when I plug 2 in, what value, what height do I get out? 3. Okay, so hopefully that'll help you along with your homework a little bit. You'll do good there.